Hello everyone. In basic tools and applications of nanotechnology, we need to study some basic tools used to study the structure of nanomaterials. Here we are using electron microscope as the main tool. So in electron microscopy, we use beam of electrons to create an image of specimen. But in normal microscope, we use light instead of electrons. So that's the main difference between normal microscope and an electron microscope. So we have in the structural determination and the structural analysis of nanomaterial, we can use two types of electron microscopes. One is transmission electron microscope and another is scanning electron microscope. So in case of scanning electron microscope, using this one, we can study the surface image of that particular specimen. We will get the surface image of a specimen. Here we can see that these essential components of the scanning electron microscope. Scanning electron microscope is otherwise known as SEM. SEM, SEM. So the essential components include uh, electron source. There is an electron source, that is, you can see here electron gun, right? So that is the electron source here. Using that electron source, we will get electrons. Next is the second important component is electron lenses. Normally here magnetic lenses used, but in case of normal microscope, we are using glass lenses, we know. So all electron microscope uses electromagnetic or electrostatic lenses. Why we are using electromagnetic lenses? To control the path of electrons. These glass lenses used in light microscope have no effect on the electron beam. That's why we are using electromagnetic lenses to control the path of electrons. So that's the second component here. So first component is electron source. Second component electron lenses, that is magnetic lenses. Then the sample stage. We can see the sample stage there where we are placing this sample. Then detectors are the important components there. Two different types of detectors we can see here. One is backscattered electron detector and the other one is secondary electron detector. The final one is a display output device. Using that device we will get the image. So these are the important components of scanning electron microscope. So here we can see electron gun is present, right? So electron gun can release electron, and there is an, you can see there in the electron beam near there is an anode. So anode can accelerate the electron, and using magnetic lenses can do what? Magnetic lenses can control the path of electrons. So after all doing these things, the electrons can reach the surface of the sample, or it can hit the surface of the sample. So sometimes the electron get absorbed by the sample. So three things here happen mainly. Sometimes the electrons get absorbed by the sample, sometimes it may be reflected by the sample, sometimes the electron can excite the surface molecule. So that molecule itself releases electron, and that electron is known as secondary electrons. So I will repeat this. We can see electron gun present there. Electron gun can release the electron and hit the surface of the sample. So anode can help there. Magnetic lenses can focus, and the electron get absorbed by the sample sometimes. It may be reflected by the sample sometimes, and sometimes the electron can excite the surface molecule. That molecule itself releases electron, and that electron is known as secondary electron. So in SEM, the SEM produces images by detecting secondary electrons which are emitted from surface due to excitation by the primary electron beam. So here electron beam is scanned across the surface of the sample in a raster pattern. Raster pattern means area is scanned from side to side. So in that way we can scan across the surface of the sample and with the detectors building up an image by mapping the detected signal with the beam position. So at each point on the specimen, the incident electron beam loses some energy, and that lost energy is converted into other forms of signals, and from that signals we will get information about uh, a sample, including external morphology, chemical composition, etc. of the molecule. So these signals include secondary electrons that produce some images, backscattered electrons, diffracted backscattered electrons, etc. So secondary electrons and backscattered electrons are used for imaging the sample. So using this secondary electrons and the backscattered electrons, we will get the image of that sample.